Scale-less absolute position linear encoder. The Motorcoder. Resolution of 1 micrometer, maximum speed of 3 meters per second or more. Sensing linear motor magnets instead of scales. Compatible with Mitsubishi and Panasonic servos. Ultra-long distance absolute position linear encoder with a battery of over 10 meters. SensorLab. First, drive the linear motor at 3 meters per second using the Motorcoder. The linear motor is driven at 3 meters per second using the Motorcoder with a resolution of 0.73 micrometers and a Panasonic servo. It is driven at the same speed using the Motorcoder and Mitsubishi servo. Looking at the speed graph, it runs at 3 meters per second and follows the command well. Second, why doesn't the Motorcoder need a scale? Other linear encoders consist of a linear scale and a reading head. After sensing changes in the magnetic flux density of permanent magnets arranged in a row using a Hall sensor, the precise position is calculated and transmitted to the servo drive through serial communication. Since the Motorcoder senses the absolute position of a pair of N and S poles, there is no need to detect magnetic poles using a servo to drive a linear motor. When the power is turned off, the polarity change of the magnet is sensed in ultra-low power mode using a battery. Long-distance absolute position sensing is possible, so there is no need for home return operation. Third, measure repeatability. To measure repeatability, I move the linear motor 150 mm from the origin 7 times, 1050 mm, and then moved it the same way in the reverse direction. I compared the position values of the optical linear encoder and the Motorcoder after a total of 10 sets of round-trip movements. As a result of repeatability measurement, the maximum position deviation is 11 micrometers, which is plus-minus 5.5 micrometers. Repeatability may vary depending on the accuracy of permanent magnet attachment and the assembly condition of the Motorcoder. Typical repeatability is plus-minus 10 micrometers. Fourth, a linear encoder optimized for long-distance movement. Since the Motorcoder does not require a scale, there is no need to precisely cut the scale attachment surface on the motor frame. In particular, when manufacturing the frame of a linear motor with a long travel distance, it was difficult to precisely machine the surface for assembling the linear encoder. The gap between the magnet and the Motorcoder is about 10 mm, which is much larger than the gap between the linear motor coil and the magnet. You just need to assemble the Motorcoder. And, by applying absolute position sensing and serial communication, it is very resistant to noise when moving long distances. If you use the Motorcoder, you can significantly reduce scale and frame costs and increase system stability when moving long distances. SensorLab.